paid me $1,000.
Well, this thing's
February the
working
12th.
really well.
And I watched the kids from February the 12th to March the 4th when they took them out of there. She owed me $2,000 on February the 12th. She gave me $1,000.
So she owes you $1,600.
Right. But I rounded off to make it just.
I'm going to have to add
She said
probably
in November,
a transistor
I
preamp
assume when you
before the volume
stopped
control,
working,
just to give it a little bit more
got
headroom.
behind. And you were behind $2,000.
So that it can accept a smaller input sensitivity.
That's not right.
Around about 200
I mean,
millivolts.
a month, that's $600.
Somewhere around there.
Okay, that's
So
what
I'm going
if I
to
owe her
work
anything,
on that
that's what I should have been
and
owing her. But I gave her the
see if we
$1,000
can
in
get
February. Because I just
better
gave her
results.
money for
I mean,
December.
it's pretty powerful as it
in
is.
February. Did you take your children
I did
home?
just remeasure
No, I
this,
took them
and
home
it's
in
putting
March.
out about
So they
400
stayed with her
milliwatts.
for another month,
So
another 4
it's
weeks.
quite capable
Yeah.
of delivering plenty of
Are they with
sound,
you now?
Yes, they are.
even with a
Who
battery
else do you live
that
with?
has
The
like
father of my kids.
8.2
You have
volt
3
in it.
children with this man. Is there
Which
any
is
reason why you're not married to him?
Greetings, the Astro 30 back here yet again looking at this little 300 milliwatt amplifier. Now, I actually was testing this last night and I actually managed to get 400 milliwatts out of it peak, so yeah, it's not a little bad little amplifier. The only problem is it requires 550 odd millivolt input for the full output, which means this pot spends most of its time near its maximum rotation to get any decent level of sound out of it. So what I need to do, rather than modifying the circuit and redesigning the input stage of the amplifier and adding a high gain stage and all that crap just to give it more gain, I'm going to add a little preamplifier before the volume pot. Also, this amplifier produces a gain of 6.5, which is the output voltage divided by the input voltage. The output voltage is 3.65 and the input voltage is 550 millivolts, which equals 6.5. And that rather large electrolytic capacitor there, that's 1000 microfarad 63 volt overkill being used as a bulk filter on the circuit here. Plus it looks awesome on the board. And this is my preamplifier circuit. We've got a basic class A amplifier with a 100k voltage divider circuit here on the input on the base. That should be a 4K7. I forgot to write the value, my bad. The output is taken here at this 2 microfarad 2. Current flows that direction. It's BC546, and we've got a 220 ohm emitter resistor and a 100 microfarad emitter capacitor. What this does is, rather than connecting the emitter directly to ground, this capacitor and resistor controls how that transistor's gain reacts to various different frequencies. The higher the frequency, this capacitor bypasses this resistor by technically shorting it out. So then we're only dealing with the emitter resistance of the transistor. So it's just basically a way to control the gain. So that's my plan today, is to build that up on the breadboard. I'm going to remove that variable resistor, ignore that op amp, that's nothing to do with the circuit. I've put an 8K2 and a 10K resistor in series to give me roughly 18K for that emitter resistor. Other than that, not much of the circuit has changed. So let me get to building and testing. I just picked up this 9 volt battery and it feels awfully warm. The only thing connected to it was a negative wire, nothing else, unless it was shorting. If I measure the voltage of it, it's now only 6.2 volt. That battery is pretty much well done. As for battery number 2, 8.75, I'm going to need to get new batteries. I seriously need to get myself a dedicated variable power supply that's capable of going between, say, 6 volt and 15 volt DC, just to test little circuits like this, because it's getting rather annoying using batteries. Okay, got the oscilloscope hooked up to the output capacitor. I'm just going to touch the input capacitor. And as we can see, it is passing the blurt test. So I know that transistor there is working as an amplifier. I've got about 8 odd volt on the output onto the collector and 8 odd volt on the input of the base, respectively. With the signal generator hooked up, it's not really amplifying that great. I honestly think that the base biasing isn't correct, so I'm going to have to mess around with that. Alright, something must have been shorted on the board because I mucked around with the biasing resistors and it's gone back to the way it was. The 200Ks, they're fine. I had to attenuate the signal on the input because it was just driving it too hard. I'm getting roughly 1.7 volt out of the transistor, so that's not too bad, but I'm not sure what I'm putting in. Okay, after digging around with this emitter degeneration resistor, I've actually increased it to 440 ohm, and I've removed the 100 microfarad capacitor to lower the gain. And with 550 in, I'm getting 4.35 out, which is more than adequate. What I want to do is I want to make this around the 200 millivolt input mark, so that when the control's wound full up, you're getting full power out. Alright, so what I'll do now is I'll hook the potentiometer to the output of the preamp, so the other half of the amplifier is now being in use, and I'll measure on the output. Preamp is hooked up to the output, and yeah, I'm now getting full power, still around about there, so the gain's too low. Well, the control's now around the halfway mark for full output, as we can see. I had to attenuate the oscillator output. I'm only getting like about 10 millivolts in now, which is annoying. I mean, it's not even measurable. I guess the way to do this now is to just hook it up to a music source and see if it's any better. Nice. Doesn't sound distorted to me. I mean, that could be the track too. But let's try another track. Can't hear any distortion. Except when I drive it. It's got plenty of power there. This turned out to be a fun little experiment. Alright, that's enough listening to that now. The YouTube audio library gets a bit boring after a while when you've heard all the tracks about 150 times. So that's proving to be a good little amplifier circuit, which I'm planning on doing something with. Is it the best preamp idea to use? No. There are better solutions, like you can use a high gain 2 transistor amplifier stage with negative feedback to control the gain of the preamplifier respectively. And it's a lot easier to do it that way. Mucking around with this and fiddling with resistor values can get annoying after a while, especially when you don't have all the test equipment that you need, especially high resolution test equipment. Like that scope there in the background, after you get below 50 millivolts of input signal, it doesn't even measure it anymore. Can't even measure the frequency. The sensitivity of that oscilloscope is not that great. I mean, it's a fine little test instrument for what it is, but it's not the greatest is what I'm saying. But it works. But for measuring low voltages and stuff, no, it's not perfect. Anyway, let's before we close this out, have a look at my revised schematic of the whole entire thing. Okay, and here's a look at the final fully drawn up schematic. Our input signal comes in over here. It's approximately 100 millivolt peak to peak, going through a 2.2 microfarad capacitor, 100k, 100k resistive divider going into the first transistor BC546. The gain is rolled off and controlled with this 1k resistor. You can put a capacitor across here of 100 microfarad if you want, so that you're actually operating this at its highest point in gain, which will put this down to somewhere about 10 millivolt, as I previously said. That goes to the collector, then it goes through a 4K7 to the positive rail, which forms our output. So rather than this going directly to the positive rail, it's going to here. So this sort of adds an imbalance in the divider. It's not exactly half voltage point, put it that way. Now, comes out of this 2.2 microfarad capacitor into our 10k log volume control. Goes through another 2 microfarad to capacitor here. 4k7 stopping resistor. It just stops any radio frequencies from being amplified. 18k ground reference resistor to this transistor BC546, which is our voltage amplifier stage, which is driving into a self-biased network comprised of these 1N4148 diodes and 2K2 resistor respectively, which drive the bases of the BC337 MPN and the BC327 MPN respectively. The 68K is providing both AC and DC feedback to the base of this transistor to control its gain, as well as to bias it. Output is formed at the 470 microfarad capacitor here into our 8 ohm speaker. Up here we've got the plus 9 volt coming in to this 1000 microfarad capacitor, which is a BAC, which stands for big ass capacitor. It is a big ass capacitor. Anyway, so I'm going to leave that on screen for you to pour over and pause and draw out and do whatever you want. I will eventually put this up online on my Patreon if anyone's interested. It's taken me 2 hours to dick around just doing this. I'm usually better than that, but at the moment I'm either not thinking properly or I'm just tired or whatever, I don't know. That's the final circuit. Let's go out listening to some music. It sounds weird because the track's heavily compressed.
Anyway, this is the Astro 30 saying if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook or become a Patreon member for as little as $1 a month. Links are in the description as usual. Anyway, this is the Astro 30 saying, see ya, have a great day. This is not over yet.